Alrighty, so this is our module 10 review, transformations and similarity. That's your standard for geometry, and then we have 3 different lessons. So the first one, you're going to be asked basically to be reminded of what happens when you dilate something. So remember that when you have dilations, the shape stays the same, okay? The size is different, okay? But you do have to remember that all the angles, that measurement of the angles are the same, okay? And then you also have to remember that the sides might be different, but they're still proportional, okay? When you compare them to each other. So there's an actual ratio, which is our scale factor. So you have to remember that, okay? The sides are proportionally proportion when you have a ratio, and then also your order pairs are also proportional when you compare them to each other, okay? So let's get to it. So they might say you have a triangle. We have to remember that the sum, okay, of all the measurement of the angles of a triangle equals 180, okay? So whatever angle you have, if you have something like this and this is 40, that must be 50, okay? If you have something like that and this is like, I don't know, 120 and this is 30 and that's 150, so that means that this also has to be 30, okay? So it doesn't matter how big or small, what kind of triangle, when you add all the inside angles, it's going to equal to 180. And we did that in 7th grade in little exploration activity. Okay? So, let me give you one example. So, for instance, I say, okay, you know, triangle, one of the triangles has measurements of 30 degrees and 100 degrees, and they don't give you the third one, okay? And there's another one that has 100 degrees and 49 degrees, and they don't give you the next one. So then, how do you know if those two are, if they're dilated, okay? If they, you know, you have a little one, I don't know, and then you have another one, okay? Without measuring, how do you know if they are dilated, if they follow the property of dilations? So the thing that you have to do is you need to find the third angle, right? So if that's 100 and this is 30, that means that this is going to have to be 50, because when I add them all together, that has to equal 180. Same thing right here. The question is, so this is 149, and so if I have 180, I subtract 149 from it, and I end up with 51. So my third angle is 51. To be honest, you don't even have to do this one, because you can say, okay, yeah, check, they're the same right here. This one and this one are the same, right? But then there's no 49 here. That means that they're not going to be equal, because 2 of them have to be the same for the third one to be the same. So then you don't have to do this, but if you need to, go ahead and do it. But as you can tell, they are not equal, okay? So we have different, actually 41 or 51. Okay, so that's 50. I don't have a 50 here. That's 30. I don't have a 30 here. So then this is not a dilation. Okay, those are actually 2 different triangles. The dilation hasn't occurred, because otherwise the angles will be the same. Okay, let's go ahead and work with the side lanes. Okay, so are those 2 similar? Okay, so are they similar because they went through a transformation and they maybe were dilated? Okay, remember I was gonna go prime over original, and we have to do for each one of them because we're checking that they're similar. So I'm gonna take this one, so I go 10 over 30. I'm gonna take this one, which is 9 over 27, and last one I go 5 over 18. Let's simplify and see what we get. I can simplify by 10 here, so that's 10 divided by 10 is 1, 30 divided by 10 is 3. Okay, that's my ratio. This one I can simplify by 9. So 9 divided by 9 is 1, and 27 divided by 9 is 3. So those work, okay? And then this one, there's nothing I can simplify by, so I just stay there. And so since these 3 are not the same, that is not a similar triangle, okay? But what if I were to change it to that? Now I have 6 over 18. I can divide by 6 over 6, which is just divided by 1. So I get 1/3. Are they all the same? Are all the ratios the same? Yes. So that means that in this case, that would be a dilation, okay? I'm actually having a scale factor of 1/3 because I'm dividing by 3. So those are similar, okay? Okay, and lastly, we're going to check with the ordered pairs. So I have to do each one of them again. So I'm gonna take this one. So I'm gonna do x prime over y prime. I have to do it for each one of them, okay? So I'm gonna take x prime 1 over 5, 2 over 10, and then negative 10 over negative 20. I'm gonna simplify and see if I get the same ratios. That one's already simplified. I'm not gonna have to do with it. This one I can divide by 2 over 2. And then this one I can divide by negative 10. So see, I'm done. I'm not even gonna keep on going because I know that they're not the same. But what if I were to give me 1/5? So those are checked. Now let's work with the y's. Okay. Oh, sorry, that should have said x. No, x, no, y prime. Now let's go with y prime over y. So I'm gonna take 2 over 10, negative a over negative 16, 6 over 12. Here we go. So that's 1/5. This I can divide by a over 8. Negative 8, so that'll give me 1/2. Oops! Nope, it doesn't work. So I'm gonna stop there. I'm not gonna keep on going. Once one of them is not the same ratio, then you're done. Okay? But if I were to keep on going, so if I were, for instance, to change this, let's see if that will work. And then, so in this case, that will be actually a similar figure, okay? Because the ratios of the x and y coordinates are the same. Okay, let's go ahead and go to this one. Okay, so you're given that triangle and you want to do an algebraic representation of dilation. So you want to go, you're doing a reduction because your scale factor is less than 1. So I'm going to take each of those points and I'm going to multiply times 1. Remember when I said in class that multiplying by 1/3 is basically the same as dividing by 3. So I'm going to call that A. So A is 3, 3. B is 3, 6, and then C is 9, 3. And I'm dividing by 3, okay? So 3 divided by 3 is 1. 3 divided by 3 is 1, and 6 divided by 3 is 2. 9 divided by 3 is 3, and that's 1. So then I can do my new order pairs, okay? So I have 1, 1. That's my A prime. Then I have 1, 2. That's my B prime. Then I have 3, 1. That's my C prime. So that is my reduction. That little triangle right there is my reduction. Okay? That check. Okay, let me go ahead and do this one. Okay, I'm gonna keep the same values and I'm gonna just multiply by 1.5. So 1.5 times 3 is actually 4.5. So that's 4.5, 4.5, 4.5 here, and then 6 plus 3 more, that's 9. That's how I do the math, because you can do this. This very property. 6 plus half of 6 is 3, so that's 9. So then I get 9 times 1.5, that would be 13.5, and then right here is 4.5. Okay, so here you go, let me graph. So I have 4.5 and 4.5, so that would be right here. That's my A prime. Can they overlap? Yes, it's okay if they overlap, okay? And then I have 4.5, 9, so I'm gonna run 4.5 and I'm gonna go up all the way to 9. Right here, that's my B prime. And then lastly I have 13.5, run 13.5 all the way to 4.5. You see how they overlap? So that will be my enlargement for that, okay? If you were to take a straight edge and go like that, this will be your center of dilation, okay? Last one, we're gonna do similar figures by doing sequence of transformations. So sometimes you're gonna be given this and you're gonna ask what happened. Otherwise, you're gonna be given the actual shape, so you're gonna have to explain what happens and how you can get from this to that, okay? So in this case, let's just kind of talk about this one really quick. What happened here, you're gonna say it was translated, so the shape was moved 5 units up, and 5 units to the right, and then 3 units down, okay? And then what happened here, you reduced it by having the scale factor of 7/10, okay? So it shrunk. So that's a dilation, translation, dilation. This one right here, I don't know by memory. I have to figure out in my brain. So I know that, so for instance, I have this shape, right? And so if the x is negative, that means that it's going to be on this other side. Okay, the y stays the same, so it stays on the upper half, but it's on this side, so that means that I'm reflecting across the y-axis on this one. Okay, and then this one, same thing, I have a hard time, so I have to kind of see it in my head. So if I have this, but then you have the y is negative, that means that it's, instead of y being over here, it's going to be over here, right? But the x is the same, so that's going to be a rotation, 90-degree rotation clockwise. Okay, alrighty, that's just a quick review. Make sure that you actually go back to module 9. Module 9 helps you a lot with this because you have to know all the transformations, and then make sure that you guys check your notes, videos, any other resources that you may have, so they can do really good and feel confident about this coming test. God bless you. Bye.